Okay, do you want to mute everybody at this point?
You know, for me to do that right now, I need to get out of PowerPoint.
Okay, hang on. I might be able to do it. Or people can do it themselves.
We can mute ourselves.
Yeah.
Why doesn't everybody mute themselves, and that way we'll save us a little.
Okay, great. Well, thanks everybody for showing up tonight. I'm Tara Schroeder and I'm joined by Dr. Newton. And we're going to put on a presentation about drinking water in the Ossipee Watershed and how to ensure that we have safe drinking water for the future. I want to start out by thanking the Tamworth Foundation for their support of this program and drinking water protection program that we're going to be doing in the coming months in the town of Tamworth, both with kids and with the general public. And yeah, thank you all for showing up. It's really important that we share this information with the community. That's our first line of defense when it comes to drinking water protection. And so I'll have a recording of this posted on our website following the meeting. All right, go ahead.
You ready?
Yep. So I work for the Green Mountain Conservation Group as the education coordinator, and we're a watershed organization that's committed to conservation protection of shared natural resources in the Ossipee watershed. And we do that through research, education, advocacy, and land conservation. So if you're not familiar with us, that is our mission. And we work in the primary towns of Eaton, Effingham, Freedom, Ossipee, Madison, Sandwich, and Tamworth. We also partner with the Saco River Corridor Commission in Maine. We were founded in 1997, largely around the threat of a racetrack development in Effingham that would have been put right over recharge for the Ossipee Aquifer. And Bob's going to talk more in depth about the Ossipee Aquifer as our primary drinking water resource. Some of you might be familiar with some of the programs that we run. Our Rivers program uses a lot of local volunteers to help collect water quality data. And we also do a lot of school programs around the Ossipee watershed towns. We've partnered with Bob since the beginning for over 22 years. And he's led many of our studies about groundwater in the area. He's presented at countless workshops to teach others about this incredibly important resource that we have in the Ossipee Aquifer. And tonight you're going to hear about the data that he's analyzed from 3 groundwater studies to date from 2009, 2015, and 2019, where we tested over 200 wells for 23 plus parameters. And I just want to mention that water is one of the most vital substances on Earth. And I often start the school programs this way too, and get people thinking about all the many uses that we need water for in our day-to-day lives. It's a tremendously valuable resource, yet it's often taken for granted, squandered, and polluted. It's a finite resource. We only have what we have, and more will never be created. Less than 1% of the world's water is readily available for human use. So it's been referred to recently by Goldman Sachs as the petroleum of the future. And even in this area of New Hampshire, our water-rich area, clean water will grow in importance in the future. And to protect it, we're going to need to work together and start thinking of a wider scale and longer term way to do so. All right, next slide. So this is a map of the Ossipee watershed. You can see Ossipee Lake in the center of it, and then the watershed boundary. And this is how we approach water quality protection and water conservation. And we have to look at it on a watershed-wide scale because water knows no boundaries. It flows across town boundaries and state lines, both over the surface of the land and underneath it. And you know, that saying that we all live downstream couldn't be more true. There's about 300,000 plus people that rely on us up here to keep drinking water resources and surface water resources clean because they get their drinking water right out of the Saco River. So if you know our watershed here, we're part of that Saco River watershed, and the water from Ossipee Lake flows to Ossipee River and then on to the Saco River.
Here, you give me that projection thing.
Can you mute your screen, mute your microphone?
Hey, everybody, just make sure you're muted because I'm hearing a little bit of background noise, and that's okay, it happens. All right, so next slide is great. All right, so GMCG's approach through research, education, advocacy, and land conservation, which I mentioned, we do about 700 or more, or we work with 700 or more students every year and hold over 30 public programs a year. Of course, that's a little bit different now with COVID, but we still are very actively working with schools and students in the area. We also have a quarterly newsletter, lots of brochures, and even a new YouTube channel that happened as a result of the pandemic. We also work with our research programs. As I mentioned before, we have done these groundwater studies with Bob and Smith College and the Rivers program, and also the biological monitoring program for rivers and streams. And advocacy, as far as that goes, whenever one of these natural resources that we depend upon is under threat, including water, we can do things like grassroots letter writing campaigns. We work with partner organizations, state and federal agencies, elected officials, and coordinate educational workshops around an issue so that we can make informed decisions based on the science. And then, of course, we're a land trust as well. Conservation of land to protect critical natural resources in perpetuity is one of the things that we do. All right, next slide. So as far as our drinking water locally goes, here's an overview. There's 14 communities in New Hampshire within the Ossipee Watershed, and you can see that in this map here. So some of them are really mostly in the Ossipee Watershed. Some just have parts of their town within the Ossipee Watershed. About 70% of the people in those towns rely on private wells, for 23,800 folks. That number increases, that percentage increases during busier months. Rely on public water systems, and of course that number also increases during busy tourist months. While the public water systems, or PWSs on the slide, are monitored and regulated, the private wells are not regulated. So that's where it comes, you know, the importance of testing comes in that private well owners, it's all on them to do the testing and find out whether or not their drinking water is safe. So these groundwater studies were important for that reason, but also to gather data and to have some baseline data for our aquifer and to be able to see if there are any trends happening. And Bob's going to get into more detail with that. Next slide.
Okay, so I'll take over. Thank you, Tara.
Yeah.
And so what I'm going to do this evening is to talk a little bit about the aquifers, and there's more than one. And so talk about a little bit about the aquifers and the water quality issues associated with each one. So just starting out, we have 3 different aquifers that are in the watershed that people use to get water. One is the stratified drift aquifer, which is perhaps, it is the best aquifer in the area. And it's composed of sorted sands and gravels, which were deposited by meltwater streams as the last continental ice retreated from the area about 14,000 years ago. Sorry about that. The next aquifer is the glacial till aquifer, and the glacier that covered the area also deposited a lot of what's called till. It's unsorted, unstratified material. And that is also used by a lot of households for their water supply, either through dug wells or even some drilled wells that use that aquifer. But it generally has low productivity compared to the stratified drift. And then it's the bedrock aquifer. And that's when you know, if you hire a driller, they're gonna, most cases, go into the bedrock no matter where you are. And the bedrock relies, for the aquifer, you rely on fractures. There's no porosity in the bedrock in this area like there is in other areas where there are sedimentary rocks. So our rocks have no porosity except for the fractures that are within them. So this provides a very variable water source. Some places there are lots of fractures and a lot of water is available in the bedrock, and other places there'll be really very little water in the aquifer and very few fractures, and they'll end up drilling a deeper well so there's some storage and maybe hydrofracking the well to try to get even more water in it. But those are the three aquifers that people use in the area. And so just as a sort of a view as what these things are, this is the Pine Barrens aquifer part in the central part of the watershed, where there's a large outwash fan built by meltwater streams. You can see the sand and gravel, and this is not at that location, but other stratified drift in the area where you can see it is stratified. You can see the layers, and they're sorted. There are gravels and there are sands. So this is what makes for the really good, highly productive aquifer. The glacial till aquifer, this kind of looks like the last slide, except but you see there's no stratification and there's all different size materials. And so this is the glacial till. And as I said, it can be, there's water in the till and it can provide usable quantities of water, but it's not as reliable as the stratified drift. And this is the reason why. If you look at the little diagram on the left, you can see all the grains are about the same size. And so you have nice big pores for the water to be stored in and for the water to move through. Where the little panel on the right, the B, you can see all different size materials. So the finer grain material fills in the holes between the coarser grain materials. And so you have much less porosity, and you have, it's harder for the water to move through the smaller pore sizes. So this is the difference between stratified drift and till. And that's the big reason why the stratified drift is so much better. And then of course, there's the bedrock, and this is not from New Hampshire, but it is granite. And you can see here a whole series of pores of fractures that are parallel to the surface. These are sheet joints, which commonly form in granites. And this is where you'd have to get your water from in a bedrock well. You have to get it from the fractures. Most of these fractures are the sheet joints tend to be more abundant near the surface and decrease with depth. So if you drill your well too deep, you're not going to get any more water than if you drill it fairly shallow. So here's a little diagram saying there's three kinds of wells in three different kinds of aquifers. We have on the right, we have the dug well, and the dug well is commonly in glacial till. It might also be in stratified drift, and that's sort of a typical old farm would use this kind of water source. The driven point is just a pipe that's perforated, screened at the end, and a 2-inch pipe, and you can just drive it into the ground to the water table and you can get water. That's really only available in the stratified drift where you don't run into lots of boulders. And then we have the drilled well, and the drilled well goes mostly into bedrock. Now, some drillers will do stratified drift, but most of the drillers, they drill into the rock. So if they're in an area of stratified drift, they'll drill right through it, they'll case the well, and they'll go down into the bedrock. And they don't get a lot of water out of the stratified drift, usually because they're using drilling mud to keep the hole open as they drill down, and that drilling mud clogs it all up around the well, so they don't get any water till they get down into the bedrock where they don't use mud. You could also put drilled wells into stratified drift, and there are some drillers that have equipment that's designed to do it directly into the gravel, and those will produce very high yielding wells. And if it's a municipal well, if a town is developing a well in this region, they would definitely use the stratified drift, and they do a special drill that would allow them to go into the stratified drift and get lots of water. And it's also possible to drill in glacial till. So those are the three kinds of wells, and I'm sure most of you have one of those three types of wells. And this is the central part of the stratified drift aquifer that we normally associate with groundwater in the Ossipee watershed. We think of it mostly in terms of this big stratified drift aquifer, but we have to realize that there are a lot of wells that are in the till and in the bedrock. And this is from a study done by Moore and Medali, a USGS study in 1995, where they identified how much water was available in this part of the aquifer. And it is one of the largest stratified drift aquifers in the state. So a lot of water is available in this area. Now, we're having a drought. So I thought I would add some information about water levels in the stratified drift wells and how they respond on an annual basis. So I have this two graphs here, and the one on the left is 10 years of water level, daily readings of water level from a stratified drift well in Warner, New Hampshire, in the down, it's close to Sunapee area, I think. You can see that it oscillates on an annual basis, up and down, up and down, up and down. And you can see here in 2016, it got lower than it is today, this is actually today's data, up through today, or yesterday. And so you can see this how it fluctuates on an annual basis. Now, I took part of the record, this latter part, just to show you what this looks like. And you can see here that going from October 2017 to October 2020, how this water levels vary throughout each year. By the way, the October 1st is the beginning of the water year. The water year runs from September 30th to October 1st. October 1st to September 30th. And you might think about why hydrologists use a water year that's not starting January 1st. And it's not because they like to party, although they do like to party. So having 2 New Year's Eves a year is a good thing. But if you look at this, it's kind of interesting because every time the well's going up, well, that's recharge. And every time it's going down, that's discharge. And if we look at this part over here, we can see that, and this happens every year, but if we just look at 2018, you see that recharge generally begins around October 1st. That might have something to do with the water year. And it goes through about the beginning of May. So in this case, there was a recharge, there's some discharge here during the winter, and then it recharge again in the spring, and then discharge throughout the summer. So almost every year, it's true that in these large stratified drift aquifers, there's no recharge in the summer, no matter whether it rains or not. And my question, all right, so you can unmute yourself if you think you know the answer. Why does recharge go from October 1st to April 1st? And why is there no recharge in the summer, even though there might be big rain events? And you can see back to the last 10 years, that's basically the way it works. There's some variations, but essentially that's how it works. Any ideas? Why is the period of recharge October 1st to, we'll say, May 1st?
Is it because of snow?
Well, but snow, we don't get snow until, December, probably, maybe a little bit in November, but recharge is starting normally around October 1st. It'll be a little bit later, although we had about an inch of rain today. So I wouldn't be surprised if there's a little bit of rain, this inch of rain might have produced a little bit of recharge. But what is it that—
How about seepage?
The seepage, so there's the discharge of the groundwater occurs to streams primarily. So, we go out to rivers, well, they're pretty low right now, but why is there even water flowing in the rivers during September this year when there hasn't been any rain at all? Where does that water come from? Well, it comes from groundwater. So groundwater supplies rivers with water during the summer months. But why does recharge? Why is recharge why does it occur from October 1st to May 1st, and then there's there's no recharge after that.
Is it the growing season, plant life?
Absolutely, 100%. So the trees suck up all the water the rest of the time. So if it rains, the water goes into the soil, the trees take it all. None of it gets down. You never reach field capacity, and you never get gravitational water moving down to recharge groundwater. It's all taken up by the trees. So when the trees shut down, that's when recharge can occur. So although we've had a very dry summer, in the case of the stratified drift aquifers, it doesn't have a major impact. Water levels might get a little bit lower. This aquifer is about, let's say it's roughly 40 feet of saturated thickness. Out here on the plains, it's more like 100 feet. So you can see that this one's not as big as that, but that's about 40 feet. So you're looking at about 7 feet of loss of water. You still have 33 feet of saturated thickness. Still a lot of water in that aquifer. But of course, if you're in the glacial till, then you don't have that big reservoir to buffer the changes. And so during the dry summer, the water runs off into the streams, and you empty those groundwater reservoirs. So the till aquifer is getting emptied. Many of the upper parts of the bedrock aquifers are getting emptied because they don't hold a lot of water. So I just thought I'd just add that a little bit to show the importance of the stratified drift aquifers as a reliable water source compared to the other two types of aquifers that we use.
Hey, Bob, can I jump in real quick before you
course.
move on? I just want to remind folks, if you have a question throughout the presentation and you want to have it asked during the Q&A session at the end, you can use your chat feature, which is in the center bottom of your screen, and just type that question in and we'll get to it at the end. All right, thanks.
Or alternatively, you can unmute yourself and ask the question. I don't mind being interrupted. So if you have a question, just ask it.
All right, great.
I don't need too many people so that we'll have too much of a problem. Okay,
All
so
right.
what we're going to talk about today is the 3 studies that we've done on water quality. So we're going to concentrate on the water quality issues and not the water quantity issues. And so as Tara has pointed out, we've done 3 studies, one in 2009 where we sampled 71 wells, 2016, 70 wells, and the one we just finished in 2019 with 85 wells. Actually, I think it's more like 91, but some of those are springs. We've done all this sampling. We've looked at everything from volatile organic compounds to trace metals. And I'm not going to talk about VOCs tonight. That was the 2016 sampling. We did a lot of VOC work. I'm going to instead concentrate on some of the other metals and what I think are probably the more direct threats that I think the aquifer faces. So we'll just say a few things to sort of introduce this. We're going to talk about elevated fluoride concentrations. And there's a lot of fluoride in the local area. That's a great thing if you have kids, because you don't have to have them have fluoride treatments at the dentist. And you definitely don't want them to have fluoride treatments if you have a reasonable amount of fluoride in your water, because too much fluoride is toxic and will cause skeletal problems with bone spur growth and things like that. So that you don't want that. So having fluoride's one of those really interesting things, and it's something that directly affects a lot of people in this area. And then so we'll talk about heavy metals, including uranium. And then I'm going to say at the end, because Tara makes me do this, something about Pinetree Power and what's happened there. Okay, so here we have the aquifer. This is the same kind of map that Tara showed with the watershed boundary. And then these are all the wells from 2016 and 2019. You can see that our approach was just to get people to let us take samples, or they take samples and we analyze them. And we didn't concentrate within the stratified drift aquifer or the till aquifer, whatever, we just took what we could get. And so you can see there's a wide range of wells, and some are in the stratified drift and some are not. So let's take a look at some of the results. So let's first talk about what we'll call natural contaminants. These are things that are coming from the rocks, minerals in the rocks. As those minerals break down due to weathering, then they release metals. And so the ones that we're most concerned about, one of the ones in New Hampshire in general we're most concerned about is arsenic. There's a lot of arsenic in some areas of New Hampshire, primarily in the southeastern part of the state, where many wells are naturally contaminated with arsenic. In our sampling in 2019, we found 0 wells contaminated that had arsenic concentrations above the MCL, or maximum contaminant level, set by the EPA. But we did find uranium, and we hadn't tested for uranium before, so we did it this time. And we did find uranium in 7 wells that were above the MCL, which was a little bit surprising. Uranium is known to be a problem in New Hampshire, again, because of the granitic rocks. And you know, we know, a lot of people know they have radon issues. Well, the radon, of course, is coming from the breakdown, the radioactive decay of uranium. So uranium is an issue in this area. We did also have a cadmium, one well with a little bit of cadmium. It was right at the MCL. And of course, fluoride, and we'll talk a little bit more about fluoride, but there was only one well that had fluoride concentrations above the MCL, which is 4 milligrams per liter. So a little bit about arsenic. Here's a map showing from AOT in 2012, showing where the area of New Hampshire where there is all the arsenic. So you'll hear a lot about arsenic, and this is a map that was done by AOT, who looked at making estimates of what the probability of you finding arsenic in your well was based on the bedrock geology. And you can see that there are some areas in the local area that potentially could have arsenic, like in Tamworth, and but in our study we didn't find any. So, but although it's a big problem in some areas, it doesn't seem to be a big problem here. Uranium, however, is. And so I took this slide from the New Hampshire DES site, where they're trying to inform people about the issues that they might have in their wells. Because, you know, you come up here and you have a drilled well, and you're in this pristine environment, and you naturally think that, well, the water must be fine, but there are these natural contaminants. So uranium is found in the area, and if you do have uranium in your well, you need to take care of it, and you have to probably go to a reverse osmosis system. Now, the uranium is mostly going to be in the bedrock wells. We're not going to see it in the stratified drift as much. Now, here are the wells, the 7 wells that had concentrations of uranium above the MCL, which is 30 parts per billion. And you say, well, wait a minute, Bob, those are all in stratified drift. But of course, they're not, because if you go and look at their well logs, a lot of these wells, they are drilled through the stratified drift. They're cased through the stratified drift and down into the bedrock. And that's probably what explains why they're in areas of stratified drift, but the wells go through the stratified drift into the bedrock. And so they are picking up uranium. So it is something, if you do have a bedrock well, you should get your well tested for uranium. Okay, so a little bit more about fluoride. About 40% of the wells in our last sampling had fluoride concentrations that were in the 1 to 2 milligram per liter range. And so this is the ideal concentration of fluoride for kids as they grow their teeth to have protect them from tooth decay. But of course, again, if your kid is getting water that's 1 milligram per liter, you don't want them to be getting supplemental fluoride. Like most people in the country have to have supplemental fluoride, but not in here for the most part. And again, if the fluoride concentrations are above 4 milligrams per liter, you can have this skeletal fluorosis, which you don't want to have your kids get. So you want to be aware of fluoride as an issue. It's particularly an issue in our local area. This is the map showing which of the wells had fluoride in the, what I'll call the ideal range, 1 to 2 milligrams per liter, shown in purple here. You can see they sort of go throughout the area. And you know, why one well and not another well? Well, it's because some may be bedrock wells, some are in till, some are in stratified drift, and it makes a difference in terms of how, whether you'll get that in your well water or not. And then of course, there was just one well that was above the 4. And again, if you had kids, you wouldn't want them drinking that water with a 4 milligram, and I think about 4 milligrams per liter, because as they develop their skeletal structure, you don't want to have excess bone deposits. So that's that. So those are the natural contaminants that we face in the area. We also have, you know, the whole lead and copper. There's been a lot of things in the news over the last few years about lead and a little bit about copper. But of course, the lead and the copper we're talking about here is not coming from the bedrock, although we do have some lead mines in the area, but the lead is not in the groundwater in those systems. But the lead is coming from the plumbing systems, and it's the groundwater moving through the house's pipes is leaching lead and copper from the pipes. So if you have copper pipes, and especially if it's an older system and you had lead-based solder coupling up the joints, then you can, if the chemistry is right, then you'll leach, if it's corrosive water, then you'll leach the lead and the copper from the water, and you'll have the wells contaminated. And so we looked at lead copper, and we followed the EPA's lead copper rule for sampling, where we took samples in the first flush in the morning before any water was run, and then after running the tap for 5 or 10 minutes, we got a second sample. And so if you look at the results of these, it's kind of interesting. You can see the wells that on the left, they're copper, and I think the MCL is 1.3 milligrams per liter, or 1,300 parts per billion. And you can see that the red represents that first flush water in the morning, and after you run the water for 5 minutes, it goes down much lower. And that was true in all cases, even for lead and copper. After the first flush, the concentrations went low. So the takeaway message here is that, you know, if you're concerned about this, just let the water run for a little while before you take the water to drink it. And that will definitely reduce the amount of lead and copper in the system. All right, and then I'm going to talk a little bit about salt. This is probably the thing that's going to have the biggest long-term effect on the most wells in the area. We're seeing growing salt contamination throughout the region, throughout the state. And so where does the salt come from? Well, we quickly will blame road salt, but as I will show you, I think that's not always the case. But road salt, certainly a source of salt in the system. And then we have landfill leachate. We also have septic tank leachate, very especially if there's a water softener in the home. So if someone puts in a water softener, the way a water softener works is you substitute sodium for calcium. And the source of the sodium is salt. It's sodium chloride. And so the system will have some rock salt you keep dumping in every couple of weeks. And at night, it will flush the system, and it's an ion exchange reaction. And all this chloride from the salt will be flushed into this, the septic tanks, which will then go into the groundwater. You know, the septic tank is not going to do anything to reduce the amount of salt going into the groundwater. It does great things with regard to the organic waste and the bacteria and things, but it doesn't do anything for the soluble things like salt. Industrial wastewater, another source, and some fertilizers. Now, there's a lot of things about salt that's not good. One of them is that it makes the water more corrosive. And so you'll see more problems with lead and copper if you have salt in your water than if you don't. And of course, too much salt will make it undrinkable as it is. So we defined contamination with salt at 250 milligrams per liter. Now, there's not an official standard with regard to that. There's no true MCL with regard to chloride. And we're going to do it based on chloride. But above 250 milligrams per liter, you can taste it. And so people generally don't want to drink water that tastes salty. And if you go much further than that, then it's just not good for you. You can't drink seawater, as we all know. So we only had 2 that were really high, but we had and if we look at the 2 that are really high, this one right here, it's not along Route 16 or even Route 41. It's off here in this housing development, in the middle of the housing development. So it can't be road salt. And in fact, that's true with the other one over here, because that also is not on 25, although it looks like it's close to 25, but it's not, it's up on a hill. And so there must be more to it than simple road salt. If we look at what we call salt impacted, where the chloride concentrations are above about 100 milligrams per liter, there are 12 wells in this last group of samples that we identified that show this increase in chloride to above 100. And the thing about the natural chloride concentrations in the area is it's definitely less than 10. It's probably around 5. So when you're seeing up to 100, you know you're getting this salt coming into the system. And the state understands this as well. There's been studies by the state and this is Laura Medali again, who worked on the groundwater in the local area in '95. She did a study of chloride concentrations in New Hampshire, doing it by town, and just looking at the number of towns where it's increasing concentrations. You can see that throughout the state between 1995 and 2005, there's much more chloride, and it's increasing. And our study sort of showed the same thing. If we compare the 2016 versus 2019, there were roughly 6 wells that were sampled in both groups. And we can see that in 2016 compared to 2019, there was much more salt. So it's 50% more salt in the 2019 samples relative to 2016. Now, there's not many samples here. I don't know if we can make a definitive conclusion from this, but it sure looks like it's increasing. The samples were taken at the same month of the year, but of course, they were both taken in June, but it could be that rain and other things happened that might impact the concentrations for other reasons. But I think given what we're seeing from the Medali study, what we're seeing, what everyone's seeing, chloride concentrations are going up. And this is not going to be a good thing. It's going to make a lot of these wells be non-usable. So then let's talk a little bit about Pinetree Power. Pinetree Power is the wood chipper power plant in Tamworth, built right on the outwash plain in the heart of the aquifer. And they proposed a year or so ago to change their waste disposal practices. Instead of taking it off-site to a waste disposal site, they wanted to infiltrate the wastewater directly into the aquifer using rapid infiltration basins. And you know, the state is only concerned about metals and not concerned about salt. So that was okay with them with that regard. There was an arsenic issue that was sort of holding them up a little bit. But the big question for the state was, well, will you be able to infiltrate the amount that you want to infiltrate? Well, they want to infiltrate 100,000 gallons a day. And that's a lot of water, but we have such a wonderful aquifer made of wonderful sand that, yeah, it just goes right into the ground. And so I call this an experiment because they were able to get a temporary permit to see what would happen. And so starting in December 2018, they got a permit to dispose of 100,000 gallons. They actually did gallons a day. I think they did 2 tests starting in 2019. This is their rapid infiltration basins. You just scrape off the aquifer a little bit down into the sand and you dump it in there and it's gone. And so they ended up putting in about 1 million gallons of waste during 2 experimental periods of disposal. Now, the problem here is this is a air photo. Let me see, this road right here is Route 41. This is the Madison lumber mill with a little pond here on Route 41. And this is Pinetree Power here. And their rapid infiltration basins were located right here. This is the Tamworth Pines well, which is a municipal well that serves a lot of the houses over here. And this is the wellhead protection area for the Tamworth Pines well, and it comes within, I think it was less than 50 feet from the infiltration basins. So they're dumping 100,000 gallons of salt water a day into this area that was essentially right next to a municipal well. And these are other wells out here. And I might add that one of these wells is the well with the highest chloride concentration we have yet to see in any of our studies. So, what is it that they were putting into the ground? It's primarily salt, salt water. It has a lot of sulfate, but the problem they have in their cooling water is that they need to keep slime and things from forming in the cooling system. So they treat it with bleach, which is a sodium hypochlorite, and that oxidizes to chloride. So you get sodium chloride as a result. So we took the average of 7 wells that were in the immediate area that we had sampled, and the average, so this would be ambient groundwater, the natural system. The average was about 5 milligrams per liter sodium, and the wastewater that they had coming out of the system was as much as 8,900 milligrams per liter. That's sodium. Chloride, 3.8, and they're 9,200. We're talking about brine that they're putting in. It's nothing you should be putting in the ground, and most states don't allow it. Any power plant wastewater to go into the ground at all. So that's one of the reasons. So we have salt potential issues. We have issues with industrial use that people are potentially putting high concentrations of nasty stuff in the water. We need to protect our water supply. And if we think about the future is as more people move into the area, the demand for water is going to be greater and greater. And if we have more droughts, then their wells are going to dry up if they're in the till and bedrock areas, and they're going to be relying more and more on stratified drift. And eventually, municipal wells are going to be the way we have to all go. And the stratified drift aquifers will be the main source of water at that point in time. So we need to protect that resource. We need to protect the stratified drift aquifers in terms of both the quantity of water that they are storing and the quality of that water. And in terms of quantity, we don't want to be paving over the recharge areas. We don't want to be putting streets and houses on areas where water would infiltrate into the ground. That will reduce the total amount of water that's available. And of course, we don't want to be putting wastewater, saline wastewater into there too, because that will ruin the groundwater quality. And so what we need to do is we need to identify these recharge areas for these principal aquifers, and we need to protect them. So that's basically my message, and I'll turn it back over to Tara.
Okay, really quickly, I just want to reiterate how folks can feel empowered and get involved. And of course, the Ossipee Aquifer Advisory Committee is the group that's meeting right now, and we're running this program through. And we began meeting back in 2016 with the support of New Hampshire DES. And our mission is to raise public awareness and assist communities with regional aquifer protection. And so this is our OAAC meeting tonight. The next one will be in November at some point. And I will let folks know when that will be and what kind of format that will take, whether in person or on Zoom. But if you're interested, or if you have folks in your town that might be interested in drinking water protection efforts, please, please, please email me, and I can put them on my email list and let them know of upcoming programs. All right, next slide. And other things that you can do to protect drinking water where we live include joining the OAAC, of course, and attending these meetings and public education opportunities. We have some great ones coming up, drinking water awareness programs throughout the month of October. That's okay. Every Monday at 1 p.m. on October 5th, 19th, and 26th, I'll be joined by Bob and our water quality coordinator and be covering various drinking water topics. So every Monday at 1 p.m. tune in online on our Facebook page, and also post those on our YouTube channel. Also, we'll have a Get Wet training, and that's our drinking water education program for schools and the public, and that'll be in January. And we're always looking for volunteers to help assist with that. You can learn more about drinking water, test your water for 6 different parameters through that program, and help with public education. And then we have our partner here, Sean Wadsworth from Albany, who's going to speak right after this presentation about the Groundwater Protection Ordinance work and workshops that might be coming up in Albany. There are a few other resources that you can check out, and of course the OAAC is the eyes and ears of our watershed. Oftentimes, if there's a water quality issue like at Pinetree Power or with the PFAS issue, leaching out of local landfills, that the way we found out was through the OAAC, and they brought those issues to our attention. So the eyes and ears of the watershed for sure. And of course, you can ensure protection measures are in place in your town. If your town does not have a groundwater protection ordinance, you know, that's something that they can adopt. Municipalities are empowered to protect their own water supplies through groundwater protection ordinances, through overlay districts, through groundwater reclassification. So you can learn about those other measures that can be taken in your town. And then finally, you can also test your well water. And we always encourage folks, if they're interested in getting a water testing kit, you can get one from us. We have the DES ones that we can provide to you, and you can always email me to find out how to get that. And this map here, I just want to point out, there are 8 of 14 Ossipee watershed towns that do have a groundwater protection ordinance in place. In Albany, hopefully, will be following suit fairly soon. But if your town is one of those towns in the blue, then maybe you want to think about applying for some grant monies, which is the next thing I'll mention. There's up to 20,000 in funding available if you apply to the New Hampshire DES, the Wastewater Protection Grant Program. Applications are due November 2nd, 2020. And if you're interested, email me and I'll give you the contact information for that and how to go about applying. So municipalities, nonprofits, regional planning agencies, water suppliers, educational institutions, conservation districts can all apply for those funds. All right, next slide. And I just want to leave you with these 2 quotes. We all live downstream, as I mentioned before. So it's all of our responsibility to protect our water resources, and that education and outreach as a tool are one of our best defenses against contamination. Additional resources are on the bottom of this slide. One-stop data. If you want to do more research and delving into water quality and water quality issues in your town, and then DES fact sheets if you want to learn about any of the contaminants that Bob mentioned tonight and maybe their health impacts or any other information about their standards and MCLs and things like that. You can go to that DES fact sheet website. And now I'm going to hand it over to Sean Wadsworth from the Albany Conservation Commission, who's going to briefly talk about their work there and what's coming up as far as that goes, and share that information so as to help other towns who might be looking towards going through this process and maybe applying for a source water protection grant to find out how they can do it too.
All right, can we just quickly say thank you to Bob Newton?
Absolutely, yes, we'll do that. Thank you.
Appreciate that.
Yeah,
Thank you, Tara.
Thank you, Bob.
None of this would happen without Tara.
Yes, true. Thank you, Tara.
No, I'll say a big thank you to Bob at the end too.
All right, thank you, Bob, as well. I'm Sean Wadsworth, and I am on the Albany Conservation Commission, also on the Albany Planning Board for the past 3-4 years. And so glad to meet you all, and thank you so much to Green Mountain Conservation Group and Ossipee Aquifer Advisory Committee for all of the work that you do. And looking forward to partnering more with you. In Albany, as you just saw on the map, we do not have a groundwater ordinance. And this was brought to our town's attention by the Upper Saco Valley Land Trust a few years ago. They put on a presentation of which towns do have protections, which don't, and what can be done. And so gratitude to Upper Saco Valley Land Trust for having that, which kind of sparked us to start saying, well, this is something we could do, and here we are. So Albany currently, we are just working through the New Hampshire Groundwater Protection Model Ordinance, and just reading through it within our Conservation Commission, our monthly meeting, to educate our Conservation Commission members. And of course, our meetings are open to the public, so just trying to get the word out to the public that way as well. And really just to define what would work for the town of Albany for water protection, and what we think our Albany citizens would adopt. So it's really, we're just in education and outreach mode. We did apply for a source water protection grant through New Hampshire DES last fall, and were awarded. So we have some small amount of money for education and outreach, and are planning to continue to work with Green Mountain Conservation Group and Tara to develop some posters or other material that we can get out to our residents, and just get them some more information about what we're discussing and the direction we hope to get the town to go to adopt protection ordinance. Really, that's the extent of what's happening right now. It is difficult with COVID, of course, to reach out to your citizenry, but we're just doing our best and looking forward to partnering with as many presentations as are coming through New Hampshire DES or your group or any other place to just get that out to the public, and to try and get our community to just recognize the value of groundwater. And hopefully the intent was to have something on town meeting March 2021, but we'll see. That seems maybe a bit of a long shot at this point. So it might be 2022 when we actually get it on our town meeting for a vote. But that's where we are, just trying to reach out, get our community knowledgeable, and try to get something on the books. So that's really it. If you have any questions for me, I'm glad to answer, and I'm so grateful to everyone here for the work you're doing and for helping network and support us in our our work to get something on the books. Thank you.
Awesome. Thanks for sharing that, Sean. And I think it's really important for, our communities to work together and share limited resources. And I think that's one of the takeaways that I had from working on through a source water protection grant with Ossipee Watershed towns back in, I think it was 2009, was that it was really effective to work together to do these educational programs and share, both having DES speakers come in and make it a regional effort, and share, brain power when it comes to writing that template ordinance and tweaking it to make it your own for each town. So I think that was really important. And if there are other folks representing other towns here tonight that can, learn from your process and kind of piggyback on what you're doing, I think that's an excellent way to approach this. And I also want to mention too that we have some programs coming up in November at the Tamworth Library, thanks to the Tamworth Foundation again, where folks can learn more about drinking water protection and some of the common contaminants, but also get their water tested for the 6 parameters that we usually test for through the Get Wet program. So that's open to the public. That's open to anyone. It'll be a Zoom presentation, and then folks can drop off their water samples, pick up water sample bottles and drop off their samples and get their results back and learn how to test for even more, important parameters like uranium, radon, bacteria, and that sort of thing. And then it's like an initial screening for your water, and you can see what other contaminants you might want to test for after getting your results. So a great program, but I would encourage folks to spread the word, get other folks on board in your town, send me your email address, and we can invite them to these upcoming educational programs and OAAC meetings. And if Sean has anything going on in Albany that's open to the public, we can also share that as well. We're going to get to some questions right now, and we'll get through those, hopefully all of them tonight. And I'll start at the top here. From Marco, for residential wells, would you strongly recommend adding any tests to the New Hampshire DES lab standard analysis, which costs $85? So the standard analysis includes a good number of things. It includes total coliform bacteria, E. coli, nitrate, nitrite, fluoride, pH, hardness, fluoride, iron, manganese, sodium, arsenic, lead, copper, and uranium. Bob, are there any other ones that you would add to that list?
I think that's probably the where you should be to start out with. I think that's what I would do. If you have unusual if you have things that you think are wrong with your water that might help you decide maybe to do something else. I think one of the other concerns we didn't talk about tonight, but that we should be thinking about is the volatile organic compounds, the VOCs. In our 2016 study, we didn't find, eventually, we didn't find any that were above the MCLs, but we found about 10% of the wells that we sampled had VOCs that were detectable. And that's not to me, that's a bad thing because, I think in almost all cases, the VOCs were coming from improper disposal of waste materials. And so if you do have some unusual chemistry, there may be some special cases where you might want to look at VOCs.
Yeah.
But I think just you shouldn't. It's expensive, so I'm not a fan of just going and doing it. You might want to have some reason to do it, but that would be the only other thing I would add to that.
So for the state, it costs $120 to test for VOCs, and a lot of these VOCs you could probably smell in your water, or it tastes funny, or if you're located next to an old dump or a gas station or something like that, I think would be good cause to add that kind of test. And then the follow-up question here, second question from Marco, do you know if we had any wells go dry in the Ossipee watershed this year? I don't personally. Do you, Bob?
I don't know for sure, but I'm sure I could say that I would be pretty sure that there were a number of wells that went dry. Although I don't have any documentation, but I'm fairly sure that there were plenty of the old dug wells that generally supply plenty of water, but they probably ran out of water.
I've recently heard last week that there were 150 wells that went dry in New Hampshire, but I don't know, maybe they're all from the southern part. And maybe we would have some more to go. I don't think this last rainstorm was is solving our drought.
Yeah.
No, and in fact, there's an article today about that, and DES James Martin said the rain will not likely make a sizable difference in the water crisis that's facing our state. And if folks are interested in learning more about what might be done with the drought and measures that the state might take in the near future, there's a meeting tomorrow at 2:30 p.m. of the drought management team, which hasn't been convened, I don't think, since 2016. But it's open to the public. You just have to RSVP, and I have a contact for that if folks are interested in attending. So 2:30 p.m. tomorrow, that's happening. Blair has asked, are you planning to host meetings for planning boards about recharge and the sensitive nature of the aquifer due to all the growth that is coming our way due to COVID? Part one. And part two, are you following the gravel pit expansion plan in Effingham on the Pine River? I don't know anything about that. So Blair, do you want to unmute and just talk about both of those questions real quick?
So the first question, I didn't realize you were doing these programs in October. That's fantastic. And I think it would be wonderful if you guys could invite planning boards and conservation commissions, if they can, to attend. I think it was back in, might have been 2000. There's a big study done about the growth in New Hampshire, like 20% growth. And I don't know what the figures are going to be now, but so many people are moving here now full-time that may have had camps. So they're converting their houses. So it's going to be impact on water withdrawal, but also on septics. They're also tearing down little camps and building bigger houses. And I know from talking to the real estate business, this is like definitely happening. And I don't think there's been time to study that. So it might be great if this group can get ahead of the curve and get planning boards to just be a little bit more proactive about looking at that.
Mm-hmm. Yeah, I know from what Moselle's been working on with BMPs and what I've heard around town on the street is that there is some work being done on at least stormwater management, which is, important part of protecting water resources. But as far as conservation of water and the location of future development, all those things, definitely, I think it would be important to just put a bee in the ear of planning boards and reach out. So great recommendation. Do you want to talk about the gravel pit a little bit too?
Sure. So no one's heard about this gravel? I did email Tim the other day because actually Corey Lane called me the other day from Porter, Maine, and she's on the planning board in Porter, Maine, and her planning board had received a notification about this gravel pit expansion. It's great. There is cross-border communication, and apparently the Effingham Planning Board always does notice if it's a water issue. They notice downstream the next over what's happening. So this gravel pit is in Effingham, but they're going to be exiting through the previous Milton Dow gravel pit that comes out near Duncan Lake. And the expansion is on the Pine River. I haven't seen it yet. She just called me yesterday, but she's sending me all the paperwork. So you want me to send you or Bob the paperwork, or because I know that both Ossipee Sand and Gravel, but also the Milton Dow pit in the past, it's really shallow there to groundwater, and they have hit groundwater in different times and had to have DES come in and assess it. But then there's the whole issue about how do they then do the reclamation on the gravel pit. So it seems like because that's also the heart of the aquifer, it'd be really good for this group to pay attention to that sort of again.
Greetings all. This is Tim. I just wanted to follow up with you, Blair, that I have posed that question with several people in town of Ossipee and have not received an answer yet on that gravel pit.
Thank you, Tim. That's great. It's in Effingham. It's just the exit's going to be through Ossipee.
Right.
Okay, so definitely something to have on our radar. Would this be something that they would have applied through DES for?
Corey said that the engineer for the project and the expansion is Jim Ryan's White Mountain Survey. So I don't know if Effingham requires them to go through some kind of permitting. I don't know how big it's going to be, but I'll definitely let you know once I get the paperwork and can share that application with you.
Okay, thanks for bringing that up. So then I'm going to move down the list here so we can get to everyone's questions. Marco says, how is climate change expected to affect our water supplies in New Hampshire? Is there more to that question? Is that it? Through the next 2 decades. Sorry. So, Bob, I don't know if you're aware of any climate change research, any current findings or.
Yeah, so the climate change research suggests that precipitation will be increasing as it has been, along with temperature. So the amount of precipitation is going to increase, and but that a lot of that increase is associated with extreme events. So there are going to be more sudden high precipitation events than what we've seen in the past. So that will tend to produce more runoff than what we would normally have seen in the past. So there's a lot of things associated with that. That is not directly related to groundwater perhaps, but is a hydrologic concern. Certainly surface water issues associated with dissolved organic carbon, with the high precipitation on wetlands producing a lot of DOC. We're seeing in New Hampshire, all the lakes, many of the lakes are getting, they're not as clear as they used to be. Of course, that's partially due to the reduction in acid rain, because the acid rain precipitated out the organic acids. So now we're starting to see that come back, and there are, of course, issues associated with mercury in fish, and all of that is associated with these extreme rain events. So there's lots of things, I think, in the climate end of it. I'm not sure I have seen anything that's really meaningful with regard to drought, but we will definitely see increase in total precipitation. We've already seen 10, 15% increase in total precipitation over the past 30, 40 years. It's pretty significant.
Great. Thank you.
Okay, and so along with that, I just want to mention that it's going to be ever more important for towns to be prepared with their, BMPs, and for lake associations to work on promoting BMPs, best management practices for stormwater runoff, to protect surface waters. And Green Mountain's done a considerable amount of work with that this past year and the year before and prior years. And some of you were at last night's presentation with the Chicora Lake Conservancy all about that. So towns can work with us to help promote that, and we can share those videos from last night with folks to help promote BMPs, but also the stream crossing initiative that we've been working on this year and we'll work on for the next few years with the New Hampshire Fish and Game Department and the Saco Headwaters Alliance folks, and looking at how resilient our communities are to flooding events. So Bob mentioned with climate change, also these more extreme rain events are going to be happening, and not only a water quality concern, but a safety concern for towns if they don't have stream crossings that are adequate to handle those flows. So those are two things that we're kind of chipping away at here at Green Mountain Conservation Group through our research and education program. Before we go, I just want to also send another thank you to Bob on a personal note. Bob's been around and has promoted drinking water protection in the Ossipee Watershed for 22 years now, and he's worked with Green Mountain Conservation Group. And I was fortunate enough to be one of the participants in the 2016 groundwater study. And it's because of Bob that I found out my personal well, my family's well, was contaminated with lead and nitrate as well. But the lead was really having an impact on my daughter's health, and she was anemic for the first 2.5 years of her life. Her body wasn't able to retain that iron that she was getting. So, you know, on a very personal note, I'm so grateful to Bob for all of his work on drinking water protection and research in our watershed. So thank you.
Welcome, Tara.
Thank you, Bob.
Thank
Thank
you,
you, Tara.
everyone.
Tara is the one who gets all these studies done.
Yeah.
It wouldn't get done without Tara.
Thank you, Tara.
Tara, this is Tim again. I don't know if you saw my question, but I think it's relatively pertinent to the conditions we have today. And
Okay.
that is with the intersection of Route 16 and 41, since they've done some extensive excavations there to realign the intersection. I'm wondering if somebody ought to contact DES to find out if anybody has done some recent testing on the wells at the pizza shop to find out if they've disturbed any ground-borne contamination from the site there.
That's a good question, an important concern. I know that there was contamination there from an old gas station across the street. Is that what you're referring to?
Yep.
Yeah.
Yep, several businesses actually.
Okay. Yeah, it's something that I can follow up with at DES and see if there's been any testing done in that area. And folks can also look on One Stop data. That's a great resource to check out, because it's a public water supply at that pizza place. You can see if they've been tested.
Well, actually, it's not, because they're still bringing water in, because from what I understand anyway, because their wells are still contaminated.
Oh, that's
I was
unfortunate.
told that they were not actively using their well for, food preparation, etc. But I can't confirm that. But
Okay.
I just happened to drive by there this morning on my way back to Ossipee, so I was thinking, gee, I wonder if anybody's contacted DES or if anybody's taken any well samples in the 4 test wells. I think there's 4 still remaining there.
I'm not sure what year that contamination is from, but I'm wondering if the plume has moved further away from that area, or if it's still located in that area.
It has and it hasn't. The last time they did testing, I believe, was 2012.
Mm-hmm. Okay, it's something to follow up on. I'll definitely look into that. Good question.
Okay, thanks.
All right, I think that unless there are any more questions, we can wrap things up tonight. I don't see any more questions on my feed here on the chat feature.
Hey, Tara, just one quick clarification for the, this is Rich. Tim said 2012, it was 2016. They did a dry well study on that area, just so everybody doesn't get a little bit incorrect information, but
okay.
And definitely, yeah, I drive by there all the time, and that's a huge concern. Obviously, you can't be shouldered with that, but I've tracked that for 2 years, and I don't, it's surprising that DES hasn't been. I kind of look when I go driving past there, and I don't see a lot of people that are testing. When they were going through with the, well, I can go and get into it later, but in any case, it was 2016.
Okay, thanks, Rich.
Definitely time for more samples,
More samples.
because that is a significant contamination area.
And of note, 2016 was a major drought year, and that's why I always remember it. That's when they did the testing, which was pretty convenient. In 2020, also a drought year. It doesn't, so it's going to be, those are aberrations and not the norm. And so that needs to be considered as well.
Rich, just had to clarify, do you know if they tested all the wells on the site there that were still on the list or not?
Absolutely not. They only did the ones that they were going to dig and put tanks in there. So the plume was right where that road, you know, I know you're comfortable with this, but on the 41-16 exchange, but on the 41, that plume's still sitting there, and it's a really big concern about whether or not it's been agitated, because obviously it goes in the direction water normally goes, which is towards the pizza place and in that direction.
Right, and my concern is that during the 2012 test, I believe they tested the on-site test wells, but they terminated that testing in 2012. I think the other test that may have been done was on, I believe there's either 2 or 4 wells opposite the site, you know, over near the pizza shop and whatever. And well, I don't know if Watson's has had their well tested, because they had contamination there at one point as well.
Right.
So did anyone ask Hobbs if Watson's been contaminated? I would think Hobbs has to test their water pretty frequently, because aren't they?
They have tested every year, and the contamination level is way below the quote unquote acceptable standards, but I don't believe that the contamination is gone.
No, I agree. And the 2016 was specific. You're talking about, I think, Pat, after 2012, specific sites, including the pizza place and a couple of other sites, were done also in 2016. But the 2016 one that I'm specifically noting is the ones where the tanks were going to be put, because
right.
Cumberland Farms had a choice of either doing like Citgo did, which is above ground tanks, but they got a variance from the zoning board for Ossipee, and that was the big thing. There would have been no issue had they done above ground. They wanted to do below ground, and it's still TBD whether or not at some point they go ahead and do that after the roadwork's done.
Right, and of course the site where the tanks were going is theoretically, at least in my impression, theoretically upstream from the contamination point.
Absolutely.
And so, you know, that test, you know, may have not really even uncovered any contaminated soil, because if we believe that the groundwater flows generally in a southerly direction there, that test would have been kind of a moot point.
Right, southerly and easterly, yeah.
Right. Anyway, it's just a thought.
Well, thanks for bringing that up, and I will follow up and see what I can dig up on whether or not there's been extra testing happening because of all that road work. And
and I'll do a little digging as well.
Okay, cool. All right.
Thank you.
Thanks, everybody. I think we're going to wrap things up now, unless there are any other questions.
Thank you, Tara.
Yeah.
All right. Thank you, Bob, very much.
Thanks, Tara. Thanks for joining us, everyone.
Yeah, thank you, everybody.
Bye.
Yeah, thank you. Bye-bye.
Thank you.
Have a great night.
You too. Thank you.